Despite the sort of slightly long and cumbersome title of this talk, essentially what it's about is this situation, which is we have a feature for a system that's going to be built of some kind, and there's a new API that's needed, or a new API feature, maybe an existing API. And you have a producing team, the ones who are responsible for building and maintaining this API, and then one or more consuming teams who are using it, who could be mobile developers, microservice developers, web apps, all of these things. And these teams need to come together and agree on an API design, which is going to be practical to implement on one hand, but also do all the things that the consuming team or teams need. And there are a few ways that you can go about considering and specifying and producing this API. And I'm going to talk a bit about kind of how this has been approached traditionally, and how API mocking can be used to produce a much more sort of optimized approach to kind of running this process. So I'll start off talking about what I consider to be kind of the classic way of doing this, and this is something I've experienced kind of in a previous life as a consultant, working on sort of big multi-API sort of microservice type projects. And we're kind of assuming this is a fairly modest feature that we're building, where the whole thing can sort of fit into, say, two-week sprints. I've seen more complex features obviously take much longer than this. But let's start with that assumption. So in this process, essentially, we start with everybody goes into a room, producing and consuming teams, sort of virtual or physical room, and kind of talks about use cases and talks about sort of examples of how this API might support them. And maybe they throw this stuff up on a whiteboard or in a shared doc or a wiki page or something like that, and sort of captures a set of notes and examples that sort of becomes, I guess, sort of an informal specification for the API that needs to be built. Then the producing team will take this and they'll go off and spend some time building a version 1 of this API, and they'll ship it into a test environment. Then once that's happened, the consuming team or teams can sort of start building their client code. And then inevitably find out all the shortcomings of the design. So things that are missing, things that aren't practical to work with once you actually sort of get into the details of them. And then there'll be this process of them feeding back these issues, and the producing team kind of incorporating them into their design. And then finally, it's sort of everybody's happy with the API design, and the consuming team can finish building their feature, and everything gets kind of published and deployed. And so there's some obvious sort of, I suppose, inefficiencies and issues with this way of working. Principally, there's a very sort of long wait time before the consuming team can start building anything against the API, and a consequence of them taking a long time to start building anything is that the feedback arrives very late. And is almost a universal law of software development is that the later you try and incorporate change into the process, the more expensive and difficult it is. If you've committed to implementation decisions around an API design that turned out not to be correct, and you've implemented those, then going and changing that design is potentially going to be quite difficult, versus if you'd arrived at a more correct design in the first place. And a secondary concern here is that that sort of at the first stage of the process, where we're kind of gathering notes and sketching things out, it doesn't sort of produce any long-term value, and things like sort of testing and verification, code and documentation generation, all that kind of thing. We have to do that using sort of other tools and kind of in a way that's out of band, and we don't get any value from that first stage in terms of being able to do those things. So I'd say the second generation way of running this process is this kind of API first approach, which is gaining a lot of traction at the moment, and has been sort of very successfully promoted by the companies that make sort of collaborative documentation and sort of API design tools. So tools that primarily revolve around collaboratively authoring OpenAPI docs. And this improves matters somewhat in that I would still argue there's this thing that has to happen before you build an OpenAPI spec. You need to come up with examples and use cases and so on like that. And something kind of out of band still has to happen to get to that point. But then there's this stage of collaboratively building this open API spec. And once you have that, there's all sorts of useful things you can do. You can generate mocks, you can generate client and server code, you can verify running code in various ways. And you can use it to generate reference documentation and feed into that process and so on like that. You probably also end up sort of shifting left at least some of that kind of feedback and verification. So you probably, in most cases, while co-authoring an OpenAPI doc, will uncover some of the sort of shortcomings of the design that you might otherwise find out later. So this definitely helps, and this sort of squashes our lead time to ship our feature down to a certain extent. But there are still some shortcomings in this, or still some opportunities for improvement. Anyway, as I mentioned, the main thing is that there is this this thing that has to happen sort of to the left of authoring the OpenAPI doc, and what I certainly observed is that most individuals and teams doing this kind of thing like to start with examples. They like to start with a specific, build up a kind of library of examples, and then eventually sort of work towards a model. The model being the OpenAPI doc. And incidentally, I think the sort of the prevalence of techniques like BDD are a testament to this sort of way of thinking being sort of quite common. So there still has to be this kind of working with examples thing that again probably still happens on whiteboards or in shared docs or whatever before you get into the sort of more formal process of building a model. As I mentioned, some verification has shifted left, but arguably there's still quite a lot that happens only after the first version of the API has been shipped to the test environment. So you still have this issue of late feedback when implementation decisions have been committed to. And finally, I'd say, although mocks being generated from within this process can definitely help, the practicalities of sort of generating mocks purely from OpenAPI is that they tend to be sort of somewhat basic and not representative of perhaps the full sort of breadth of behavior and sort of complexity of the API that you're really working on. So and this feeds into the previous point to some extent, that the feedback that derives from those kind of nuanced cases sort of only happens when you get a real implementation. So as I say, I think API mocking as a practice has some answers to some of these issues, and potentially offers an even more sort of optimized process. I'm going to digress slightly before explaining that process in detail by just for the purposes of anybody who is maybe not so familiar with API mocking, just give a quick overview of what it really means. Essentially, all it is really is about simulating the behavior of the API, so the visible behavior of the interface, but without implementing all of the state and behavior and everything else that would go behind the real thing, and therefore making it quick and easy to build these things, to change and run them, all that kind of thing. And as we'll see, by having this capability, there's a load of benefits in terms of your process for producing APIs. Incidentally, sort of, I think mocking is generally seen as a sort of test and development support tool primarily. And what I'm going to talk about is really using it as a prototyping tool, which is a sort of lesser, maybe lesser used technique for it, but I think a very powerful one. So anyway, so this is what I'm going to refer to as mock-based prototyping. So this is where, rather than this sort of whiteboard or shared doc or wiki kind of based process for producing examples, we instead build a running mock API as our set of examples. Because fundamentally, a mock API, the way you build them up is essentially exactly that. You're giving examples of requests and responses that represent particular behaviors that the real API will represent. So in this process, we start by building this. We go in we do away with the whiteboard or the shared doc, and we build the mock directly as we're having our discussion around use cases and examples and all that kind of thing. And as soon as we produce this mock, we're then in a position to, the consuming team can start building their client code straight away. They've got something running that they can build against, but potentially, if the mocking's been done well, represents a much sort of richer selection of the behaviors of the API than the a generated mock might do. And likewise, the producing team have got something sort of on which they can start building straight away as well. So this enables a lot of the work to sort of move left in the timeline. A lot more sort of parallelism to occur. And it also means that because the consuming team have started building very early, they can continuously feed back these, these kind of improvements to the API design, hopefully very early on in the process for the producing team. So when the cost of change is much lower, they can go back. The mocks can be updated to reflect what the sort of new understanding of the API design should be, and a more correct API design can be kind of fed forward into the production process. So this is also good. And then another thing we can do, and I'll get into this a bit more in a moment, because this is something that we're starting to do with WireMock, our main product at the moment, is once you have the mock, you can generate an OpenAPI doc, and from that you can generate documentation, and you can do all sorts of useful things that are productivity aids for teams consuming these APIs in particular. And as a result, this means that we can further squash down the lead time that it takes to get this sort of completed feature out of the door with the both the API and the client code kind of complete and running. And although I'm talking about this in this sort of slightly hypothetical setting, we learned about this process really from our for observing some of our customers doing it. Even though we didn't start out building the product with this as a sort of primary use case, some of our customers have told us that this is what they're doing, sort of minus the OpenAPI generation stuff, which we're only just starting to do. But we have a number of them saying this will often save weeks and weeks of lead time, sort of end-to-end shipping features. So they see it as a really valuable productivity tool in terms of reducing cycle time and reducing these kind of inefficiencies in the process. So yeah, just to sort of summarize the benefits then of this approach, we get to start with examples in a way that we get long-term value from, rather than something we throw away. We get something that's sort of runnable straight away. We get help generating our OpenAPI spec. We don't have to hand write it from scratch. We can generate a lot of it. We can parallelize the work. Consuming team starts early, feeds back continuously into the production process for the API. And then at the end of this, you have some sort of artifacts with long-term value. So you have a ready-made sandbox that can be used in sort of CI/CD, and for developers, say if you have a whole load of different consuming teams all building different things, then you have something straight away that they can start building and running their tests against. And because we published this portal off the back of it via the OpenAPI doc, we make it really easy for new consuming teams to onboard and understand how this API works and sort of start being productive with it. So they say you should tell rather than show rather than tell. So I'm going to give a quick demo of a feature of our product, which is in beta at the moment, but it's the sort of shows the kind of basic workflow for mock-based prototyping and how it looks in practice. So I'm going to switch over to, so this is WireMock Cloud. This is our main product. I've just got one API here at the moment that I created earlier, but I'm going to create a new mock API of this OpenAPI type. I'm going to call it OpenAPI demo, and I'll give it a nice friendly domain name. Okay, so what we have here is a blank mock API, and because I said it was the OpenAPI type, I've got this extra page down here. So what we have here is essentially a kind of pre-generated sort of OpenAPI document stub. It's not very interesting at the moment. It just has some kind of header information in it. And then we have this enable public API documentation switch. So if I switch this on, this is going to publish a sort of a kind of API portal page, sort of a documentation page. And so if I click on this, then we see what at the moment is not a very interesting, sort of empty documentation page. But as we'll see, this will get a lot more interesting as we work. So now that I've done this, I can go back to the stubs page. So stubs is the sort of WireMock word for examples, essentially. Different tools in this space have different, different naming for these things. But essentially, it's all about these kind of request and response examples fundamentally. And what happens in this workflow is as we create the examples, it will generate the OpenAPI, and that will populate the documentation portal. So let's just assume that we are that what we're making is a sort of contact manager type API. Sort of it's a CRM tool, and we want to manage contacts. So I might want to start with my first use case is I want to be able to retrieve a single contact record. So I'm going to create a stub, my first example, which is get a single contact. My URL structure might be a version, and then I have a contacts collection, and then I have a contact ID as my path variable. So this stub, currently would match any incoming GET request with this URL structure and any contact ID in here. But actually, to get a bit more specific, we might want to say that for this particular example, we want a contact ID of 12345. And let's say that when we receive this contact ID, we're going to return a very, very simple contact record. The world's simplest contact manager. Okay, now if I save this, so this is a running stub. So I'm just going to pop out the test requester, which is the sort of Postman-ish module in here that allows you to make test requests. It pre-fills it with everything that you've put into the stub you just created. So all I have to do is hit send, and this is showing me that I make a request to that and I get back the data that I wanted. So that's all good. So we have our first running stub in our mock API. If we go back to the OpenAPI page, you can now see that there's a whole load more data in there. It's created the path and the response. It's added a schema, and it's added an example and all this kind of stuff based on that example that we just gave. And if we go to our portal page, you'll see it's added this extra endpoint. So we can go and look at the details for this endpoint, and it gives us all sorts of useful information. It tells us what the request parameters look like. It shows us an example, and shows us the structure of the response body. It's sort of broken down field by field, based on the schema that's in there. And we have the ability to go and grab code snippets. So consuming teams who are looking at this can go and find whatever technology they're writing their client code in, go and grab a code snippet and use it to kind of get started writing their client code. But the best thing about this is because this is based on a running mock API, we automatically get a sandbox behind this API doc. So this is an actual URL run, that really is running this mock API that we're working on. So, and it's pre-filled here the contact ID with the example that was derived from the stub that I created. So I can hit send API request here, and that's made a real HTTP request to my mock API, and has brought back this response. And I could use this, as a client, so if I copied and pasted this code in somewhere else, I could run this in my unit tests or in CI/CD or whatever, and I would get this same response back. So I can use this sort of straight away as a test environment to build against. And we can carry on adding more stubs. I might want to create a post example, for instance, where I'm expecting a contact, and I could, for instance, be very specific and say I want the body to look kind of similar. Maybe I don't want an ID, but I want a something that looks like something specific, shall we? we do this, and then we want to say maybe this is just a okay response. So there we go. Now in doing that, we'll see this the post path and route that's been added onto here, and you know, in a similar fashion, the scheme has been filled out, all that kind of thing, and you know, we flip over to here, and now the route's been added here as well. So hopefully that gives you gives an overview. That's the process in a nutshell. I hope that gives a good overview of it. And that is pretty much it, I think. So yeah, thank you very much for watching.